Alright, we're looking at a block sitting on a ramp, and the point of the problem is to figure out what is the force of friction, what friction must there be to keep this block from sliding down the ramp. So first thing you got to do in a ramp problem like this is put the components of gravity on the block, and that is one of them is straight down in the center of the earth, 90 degrees to the ground, and that's called the weight. Usually it's we write it as mg. Maybe you could write w, you could write fw, whatever you want to use for weight, but you end up doing mass times gravity for weight. The other component is into the ramp, and that's 90 degrees to the ramp, and that's called the normal force, maybe Fn or just N. And then there's another force that makes the block want to slide down the ramp. Call that one Fp. That one's also up here. That's the parallel force that's causing it to go down the ramp. Now, if friction is going to keep this thing from sliding, then the friction here, I'll write Ff for friction, must be equal to the parallel force. So what I just said was that Fp is equal to Ff, or vice versa. Now, you can find the amount of friction, or you can find the parallel force by analyzing this triangle here. One thing you need to know is that this right here, this theta and this theta are the same. These two triangles, the big one here and the small one, are similar triangles, and that angle and that angle are the same. And you can prove this with geometry. If you look, you got a couple parallel lines here with another one dividing them. You can do some opposite interior angles and figure out that these are in fact the same angle. So once you realize that, you have this picture drawn right here, this triangle. Now all we got to find is the parallel force, because the parallel force is the same as the friction. So what I would do is put in how you find this parallel force. Now, if you're good at your triangles, this is the opposite side, this is the adjacent side, and this is the hypotenuse over here. So we're going to use sine with the parallel force and write this, that sine of theta is equal to the parallel over the weight. Okay, so bringing the mg over here, I can write an equation out that says the parallel force is mg sine theta. And it's always that. For every time you break up forces on a ramp, the parallel side is always mg sine theta. Just like, you might not need this, but just so you know, over here on the normal side, that's the adjacent side. So that would be cosine theta is equal to mg, or normal force over mg. So normal force can always be found, always, by mg cosine theta. And after you do a few of these for a while, you start to just realize that parallel force is always mg sine theta, normal force is always mg cosine theta. Alright, so all I need is the parallel force to find the answer to this problem, which is how much friction is needed to keep it in place. So if I say parallel force is mg sine theta equals Ff. And that's what I need to know right there. So, for example, if they told me the mass of the block and they told me the angle of the ramp, I could find out how much friction needs to be necessary to keep it from moving. I could throw you a couple numbers here. Like if we had a mass equal to 10 kilograms and an angle of 30 degrees, then if I put in my numbers, the friction would be 10 times 9.8 times sine of 30. Whoops. Let's make that a 30. So putting it in, what is that? That's sine of 30 is 0.5, so half of 980 is 490. So the friction would be 490 newtons. Okay, if that's what you're trying to figure out, just the force of friction, then that's how you would do it. Now, if they were asking you what coefficient of friction is necessary to keep it from moving, then you would have to incorporate that mu is Ff over Fn, So you would have to do both of these, put both of those in. It actually simplifies out, because if you look at it, it's mg sine theta over mg cosine theta. And sine theta over cosine theta right here, the mg's cancel. And this is actually tangent theta. So you end up with this equation that says mu equals tangent theta. So if they did ask you what coefficient of friction is necessary to keep it from sliding down a ramp, all you need to know is the angle. And you take the tangent of it, and that's the mu that keeps it from sliding. Okay, hopefully that's what you were looking for.